Okay, so we're going to pick up from the end of the simulation tutorial, or scene file 7, and just going to get ready to start importing this geometry or the particles into Solaris. I'm just going to rename this node here to load sim cache, and I'm going to put down a null down here, and I'm going to call this out. I'm just going to bypass the retime nodes for now, just so it plays back a little bit faster. If we look here, we can just verify the information we have. We have P and P scale. We know that Karma or Solaris will natively recognize P scale, so we don't need to do any renaming or variable or attribute remapping or anything like that. I'm going to go to the stage context. I'm going to make a SOP import, and I'm also going to make a grid. So this is going to be our ground plane. We can go into the Vulkan viewport for right now. And this is our Cymatics. And here we can grab our reference to that null. So we have the particles coming in. And I'm going to do another merge down here. So this way we can get a camera. And I'm going to use another transform node beneath the camera to reposition it. And I'm going to use a look at constraint with an X form. And then rewire this like that. We can set this look at to be the second input. And then for the target, I'm just going to rename that. So that will get that X form. This one's getting the camera. If we look through, just put the display flag down there and look through. We want to look through negative Z. This is a useful way of working so that as we move this transform node around, whether you move it left, right, up or down, in and out, or anything like that, you'll always keep the camera focused on the center of the scene. So this way we don't have to worry about always managing the rotation of the camera. It will just be locked in always to be looking at the middle of the scene. And I'm just gonna rename some of this stuff so it's a little bit more clear as to what's going on. And the next thing I'm going to do, if we look at the timing here, you remember that we basically set this pattern to update or clear and reset every 75 frames. So if we add animation, we want to work in that same cadence or timing or rhythm. I'm going to bring in some nodes here that I added keyframes to. If you look at these keyframes, these are basically spaced out so that every 72 frames we're arriving at a new camera location or a new composition. And I'm just going to bypass the ground plane so it's a little bit easier to see with the GL viewport. So every 75 frames roughly, the camera will reposition itself to a new location, allowing for a new framing of the particles. So we're basically starting from this really low angle, low point of view, and then the camera will keep kind of pulling out, rotating, so it's getting higher and higher until it's directly above the particles. And then at the end of this animation, I've animated the camera to fly back in to the middle of the composition, or the middle of the scene, basically with the idea that everything can be looped. So you could cut or crossfade from here back to here at the start of the animation. And if we bring up this other network view, I'm just going to go back into our SOP area here. And one thing we can do with the time shift, I'm going to set these ones aside for right now. And I'm going to take FF plus 75 times 4. And this will allow you to basically offset things in factors of 75. So if you keep that 75 and then just change how much you're scaling that by, this just lets you offset into different kind of sections of the simulation. But because we're incrementing everything still by 75, we know that our timing and cadence and everything of the particles will keep matching the camera. So this was a useful way that I found to basically slide or shift the simulation around so that I could get different compositions with the camera, but still keep the camera animation and the timing so that it was lining up and I didn't have to worry about redoing any of that stuff. Okay, so now that we have our time offset set up, I'm just going to add in one more new number. So we're doing 75 times 11. And this is what I found out ultimately gave me these best compositions that fit in the frame nicely, and the transitions and everything worked pretty well. Now we can start adding lights and camera and everything like that. I'm going to go into Karma XPU. I'm going to add a quick node just to use temporarily. We're going to disable the f-stop. So you just set that to 0 and it will disable depth of field. And we can add a light. And it's up to you if you want to look through the light or just move it around by hand. I'm just going to set it up like this. We can do a rectangle light. I'm going to make it pretty big, a little bit brighter. I'm going to turn on the ground plane. And I'm going to set it so it's facing the other way than the camera is looking. This way we'll have more of a glancing angle, or like a backlight kind of room light type of effect. And something like that. And you can adjust this spread if you want for Karma to focus it more, to get maybe a nice fall off or something like that. So if we jump back into the camera now, you can see we're getting a nice backlight kind of rim lighting type of thing. And the next thing I'm going to do is start to set up materials. I'm going to make the material library over here and wire it in to this merge. And we're going to use this to generate materials, and then I'm going to use an assign material down here. So this way you can edit the materials without affecting or making geometry recook or causing other scene graph reevaluations and stuff like that. So I'm going to make a material X builder. We'll have one for the ground, and we'll have another one for the particles. And if we go up right here, we can start to set up these assignments. So we're going to start with 2 material assignments. And it's up to you how you want to name these things or set them up. one of the things I started doing recently was setting up my names like this. If you drag and drop it like that, but then in here you put in up full path, like that, this will still give you the correct evaluation. Let me just set this one up to compare it. The reason I'd like to do it this way is if you start to rename stuff later, this name will automatically update. The expression will link the name to the node. If you do something over here, this expression won't update. So that's one of the reasons. Depends on how quickly you're working or stuff like that. But for example, scenes or stuff like that, I like to take a little bit of extra time to add the expression just so it will keep updating even if you rename the inputs. So you might want to reuse this scene with different particles that aren't cymatics, that are a different effect in the air or something like that. So it's to use as a template, it just makes things a little bit more flexible. And also a similar thing for the materials that are inside of here. If we drag and drop this, I'm just going to copy it like that and do that. We can do, let me actually just grab it like this. So we'll just start with that and then do, we can grab this here. And we can add these backticks for a string expression. And then it should be working. In this case, we want to use op name like that. And then we want to add the prefix for where they are in the scene graph. So if we look at the Solaris scene graph tree, you can see materials, and then we have this stuff there. So we're basically looking to replicate what you would get if you dragged it in like that. So in this case, I can grab that, and put that in. And we basically have the same thing. I'm just going to pin the view. If we take the ground, I'm going to start with doing a very low diffuse color and also a pretty low specular. And then with these particles, I'm going to reduce that a little bit, and I'm going to increase the roughness a little bit, and I'm going to leave those where they are right now. So you can see as we get this glancing angle from the lights of the specular highlight, there's like a moment there where you get an interesting lighting effect, and then as we get up into the more overhead view, the camera is, the lighting and everything like that is just more flat. It's using more of the diffuse component. So I'm just going to turn on the ASIS, just so we have a better sense of the actual light, and maybe adjust that exposure a little bit. And I think that's starting to look good just for a first pass. All right, so now we want to start adding a little bit of polish to everything. And one of the first things I'm going to look at is the ground plane. If we go into the Vulkan viewport, or if we just look at the alpha channel, you can see that that grid is a little bit too small for our simulation. So we want to keep that extra stuff on the sides. So I'm going to go in here and just increase this size to 15 by 15. We can see that it fills the whole composition, or the field of view of the camera. And I'm also going to use UV texture so that we'll have texture coordinates, and we can assign what I want to do is basically assign some texture maps here to break up some of the cleanness of that reflection. I'm going to rotate the texture coordinates 45 degrees so that we're looking kind of diagonally along them. That might be able to hide some kind of repetition artifacts. Like if you're using a tiling texture, it will be easier to hide it if you do it diagonally like that. Then we can go into the material library. I'm going to look at the ground, and I'm going to use Material X image, and we can use the unlit surface if we just want to preview the direct result of this. I'm going to switch it to vector 3. So we want to use this map that I've included here in hip/text. We want to use this not for color purposes like albedo or diffuse or anything like that. It's more of like displacement or specular roughness or something that you wouldn't want color, curves, OCIO profiles, sRGB, or any of that stuff applying the color conversion to. So set it like that, and we can see that we're getting some nice imperfections already. I'm going to use vector separate 3. So just allows us to convert from a vector to a scalar. And the range node as well in Material X is pretty useful. This will allow you to adjust the input and output ranges as you may need. And it also has a gamma in the middle, which is also pretty useful just for remapping values of textures. So we can go back into the surface shader. I'm going to give us some room. And then in this specular, we can use a few things here. One of the things I want to try to use is the anisotropy. I'm going to disconnect this. You can see already with that we're getting some interesting results just because this is able to skew the direction of the highlights so that they're no longer directly parallel with everything. The anisotropy allows them to skew or get kind of pushed to the sides. I'm going to do another one that will affect the roughness. And I'm going to remap this one a little bit. So our high should be maybe like 0.5. Maybe I'll check 0.3. And then the low will be 0.5. Something like that is starting to feel a little bit more natural. You can play around with these values as well. I think in this case I might just use the gamma. Something like that. And the last one you might want to take a look at would be the rotation. This as well can be used to further affect the anisotropy and the direction that the specular highlights are getting moved to. And then I would say overall, if you want to adjust the degree of this effect, the more similar you make these numbers in the input and output, low and high ranges, the closer, the less you'll see this overall effect. So for example, with roughness, if I start to go up a little bit higher there, you can see that we're kind of reducing the overall visibility of that effect. And the same thing with some of these other rotations and stuff like that. I think this is working good enough for now. I'm going to leave it how it is. And I'm going to go back up to the particles. And I'm going to adjust these base color here to 1, just so they get a little bit brighter and they aren't competing as much with the specular highlights, they kind of sit brighter than, or it's harder to lose the particles in the specular highlights if you make them a little bit brighter. And the next thing we're going to look at as we continue to polish things up is, earlier I just set this f-stop to 0 to effectively disable depth of field. And the reason that I was doing that is because as we animate, the camera translates. We would need to always be updating this focus distance to match the camera's new distance in world space from where it is all the way down to the origin. And hand animating that would be pretty tedious to have it come across without any mistakes or anything like that. But one thing we can do is we can actually use this look at target as part of our scene graph information and compute the focus distance on the fly using that. And the way that we can do that, I'm going to merge the actual X form into our scene graph tree like that. And then if we use a wrangle, we can use some vex code to retrieve this information. I'm going to paste some code in here and then add the parameter generation. So we go back looking through the camera, and I'm going to drag that to there like that. Now you can see that this is automatically overwriting this focus distance attribute of the camera primitive. So if we look here in cameras, we have the camera primitive, and then if we go into the Solaris details, you'll see this focus distance. So this is where this name of the USD attribute that we're editing using this vex code is coming from. So this allows you to efficiently set focus distance on the fly. You can even do other, you adjust the f-stop or other things like that procedurally as well if you wanted to. But in this case, I found it easiest just to set this bit, derive it from the distance of the camera to this look at target. And I did do a little bit of an offset here, just because the particles sit above the ground plane. So this was just like a slight offset to lift the focal plane up a little bit away from the ground plane. But other than that, that's pretty much it. And there's a few more things we want to add relating to the camera and the lens and all of that. And I'm just bringing them in now. This node right here creates a camera lens shader. If we go back here, you can see now we have a material custom lens properties. So this is making a lens shader. Previously, I think I used a separate material network, but I think this is a little bit more clean to do it all in line like this. And this just makes a lens shader. I'm using the polygonal bokeh, and then I'm also adjusting the anisotropy to make it look a little bit more anamorphic, like a traditional film camera that would be squeezed through the lens and everything like that. Then after we create the lens shader, the lens properties, we just need to apply the lens shader to the camera. We can do that with another edit and stop like that. And that was like I got it here before, just the camera edit. So you can see this adds that new lens shader. We get a little bit, I was just trying to make it look a little bit more photographic or dynamic. And lastly, this motion blur is being used to add camera blur from just the camera translations. So as the camera is shooting away from stuff, like pulling away or pulling in, this is how you'll get the translational motion blur. like everything's kind of going radially from or to the center. And if we go into the geometry, I'm going to add a trail node here and just set that to compute velocity. And then this way we'll have particle velocity or motion information sufficient enough to compute velocity blur for that. So our velocity blur should be fully sorted now, as well as our camera depth of field and some of the more like photographic nature of the effects. And next, I'm going to improve the lights. Right now we just have this single light that's right behind everything. And I spent a little bit of time setting up kind of like a light rig. So I'm just going to drop that in. We can delete that one. And this is a similar idea, but there's this has some colors. Some of it's cooler and some of it's warmer for the lights that are behind the scene. And the spreads on them are a little bit more narrow and broad just to get a different roll-off to everything. The other thing that I added was these expressions here in the rotation of two grid lights. So during this whole animation, these two rectangle lights are just going to be constantly rotating around the scene, just spinning around. And the reason I was doing that was to get more interesting diagonal shafts of light or chasms of light or whatever that over time would catch interesting angles or give you a more dynamic composition. So you just have things falling into shadow or coming out of shadow the whole time. And I found that kept things a little bit more interesting as well. The only other thing that I added in this was this light blocker. And this is just a tube. Let me go into Vulkan. So it's just a section of a tube, and it's lined to face the camera to kind of go between the camera and everything. And the reason to do this is that without it, we might get too much kind of like a headlight. So if I disable this, you can see everything's getting too flat because we're basically hitting it with a light that's perpendicular. It's just lining up exactly with the camera. So it's kind of killing all of the shadows or the interesting stuff that we might have going on. So that was another thing that I added as part of this light rig, just to make sure that we don't have too much light coming from the front direction. And then in here, this is just setting the render visibility of that geo just to affect shadow rays. So now we're going to finish adding the rest of the time remapping functionality. Like I said earlier, we did all of our animation. All of these keyframes were matching the original simulation pacing and speed. So every 75 frames, we had a new pattern being shown. But if we want to do some more exaggerate time remapping, I'm going to grab some nodes here. I'm going to put them in and just insert them like that. And I'm going to delete this one, and then I'm going to insert the time blend at the start. If you want this to be a little bit more accurate, you could do subdivision. That'll just give you a little bit more interframe samples of interpolation. And once we put these in, you can see that our composition no longer looks like what we had when we were setting it up. So what I did here is I cached, or I stored the current frame just using $FF, and I put it in a detail attribute called current frame. And then I did the time remapping with this lookup curve that basically applies this speed curve between every 0 and 75 frames, or in increments of 75 frames. And lastly, I did just multiplication to get 40% of the original speed. And the reason I did this was so that I could render stuff closer to 60 frames per second and just have smoother motion overall. So now we want to carry this time remapping over to Solaris, and I'm just going to use the time shift nodes, because basically our camera and the lights, they're still behaving or using their original keyframes. So to retime them, we can just use, I'm going to hit Control-C here. Depending on how you have things set up, you should get the node path in your clipboard, and we can use this to get a detail attribute, and it's going to be the current frame that we set up here. And the index is 0, it's just a single float. So once I put that in, this will pin or restore the camera back to being where it was at this point in your SOP chain. This is a more valuable way to work, like non-destructively, I guess. So you can layer any time remappings on top of your original work. You don't have to worry about changing keyframes or adjusting anything else like that. And I'm also just going to apply it over here to the lights. And I'm just going to set it like this to the light primitives. The reason I'm doing that is because I want these rotations that get applied to the lights to also get sped up or slowed down, so that the motion and the speed of them will be tied to the simulation. So if the particles slow down, kind of like a bullet time effect, the spinning lights will slow down as well and get kind of a suspended moment of suspended animation. And lastly, we're ready to set up our render wraps with the Solaris outputs. I'm just going to use that Karma preset that gives you a couple nodes. We can connect it like this. I'm going to go to 2048 to get a 2K, something comparable to 2K resolution. I'm going to add extra diffuse bounce, so we should get more GI bounces between the particles. Under camera effects, I'm going to turn on velocity blur. This will let us use the point velocity for these particles to compute the motion blur for them. And that's pretty much it. One thing I did find I had to add was more path trace samples. When you start to do really exaggerated bokeh or depth of field effects to resolve some of the noise, the sampling errors in the out of focus areas, sometimes you have to just increase kind of like the brute force overall samples. They did add a new pixel variance thing that this lets you shoot enough rays just to resolve to a certain threshold of noise. And you can play around with this. I think I tried something like that. Previously, this has just been set to uniform with Karma XPU and everything happening on the GPU. I don't know how much of a speed benefit or anything like that it really gives you. It could just be wasting time, kind of like troubleshooting or typing in values. So I didn't have too much luck with it, but I was just trying it out. And other than that, we're ready to go render. In this case, everything is set up okay. I'm not doing any super specific project directories or anything like that. And then you can use this whole scene time for the start and end. Sometimes I turn off the snapshot intervals, just because the frames are so quick, it doesn't really make too much sense to me to waste time saving snapshot files of a partial image. Like it just takes a couple of minutes to render, so it's not a big, you don't need to waste time with that, in my opinion, for fast GPU renders. So other than that, we should be ready to go.